In the next few videos, we're going to be discussing a regression line, which is the line that best models the linear dependence of y on x. And so in this video specifically, we're going to learn how to identify the y-intercept and the slope and how to interpret those values. So in this class, we typically give students the equation of a line, which is y equals mx plus b, but sometimes you may actually already see your regression line drawn on a graph. And so if you want to identify your y-intercept, you can either graphically do this by looking for the point that intercepts the y-axis, or numerically we always state that the y-intercept is where x is equal to 0. So if you set x equal to 0 in the equation of a line, which is y equals mx plus b, then you know that b is the intercept. Similarly, if we're looking at the equation of the line y equals mx plus b, if you've taken a basic math course, you should already know that the slope is the number that's attached to your independent variable. So now that you know how to identify the y-intercept and the slope, we can interpret these values using the equation of the line. So anytime you interpret the y-intercept, which is the b in the equation, you always want to state that when x is set equal to 0, the y value is going to equal the y-intercept. And then for the slope of the equation, there are two scenarios. You can either state that as x is increasing by 1 unit, the y will increase by the slope, but if you have a negative slope, you're going to state that as x increases by 1 unit, y is going to decrease by the slope. So let's understand these interpretations through a simple example. Let's think back to our example of a predicted GPA as our dependent variable and the number of credits that a student takes per semester as the independent variable. Then in this case, if we want to interpret the y-intercept, in this equation, the y-intercept is 3. So we want to state that when the number of credits per semester is set equal to 0, then the predicted GPA for a student would be a 3.0. And notice that I'm using the terminology of the problem, so you don't want to just say x and y. Make sure you're stating the independent variable and the predicted value. Now, as for the slope of this equation, it's a positive value, so it's going to be increasing. So we would state that as a student increases their credits per semester by 1 unit, then the predicted GPA is going to increase by 0.2. So if we look at another example, you may also have an equation where your slope is negative and it's not in the form of y equals mx plus b. So make sure you know how to identify again the y-intercept in this problem is still 3, but now it comes first. And so we can again interpret this by stating that if you set the number of credits a student takes per semester equal to 0, then the predicted GPA is going to be a 3.0. And if we want to interpret the slope, now we have a negative slope. So instead of stating that it's increasing, we're going to state that if you increase the credits per semester by 1 unit, then the predicted GPA is now going to decrease by 0.2. So this is how you interpret the intercept and the slope. And in the next video, we're going to talk about prediction and drawing the physical regression line.